apply differential operator on any function, it gives you a new function. आप डेरिवेटिव निकालते हो ना, कोई भी फंक्शन है, सपोज x², उसका डेरिवेटिव निकालते हो, तो यू आर गेटिंग सम न्यू फंक्शन 2x. सेम लाइक दैट इंटीग्रेशन करते हो. If you are doing any integration of any function, तो ये आपका इंटीग्रेशन का नया फंक्शन मिलता है. So any operator it is used to transform the function. Now CR जरा मुझे बताते रहना कि पार्टिसिपेंट्स में इज एनीबडी देयर, एडमिट करना है तो. मैंने आपको बोला कि यू हैव टोटल दिस टाइप ऑफ फंक्शन ना, ILATE, इनवर्स, देन logarithmic, algebraic, trigonometry and exponential function. If these functions are there, and if I ask you कि in which function you want to convert the given function, which as per you will be the easiest function from this, who will tell me? Inverse, Laplace, algebraic, trigonometry and exponential. ये 5 फंक्शन में से किस फंक्शन में मैं कन्वर्ट करूं तो मुझे वो इजी हो जाएगा, काम करना, आगे का काम करना इजी हो जाएगा? हाँ, algebraic, very nice, very nice. algebraic में कन्वर्ट करूंगी मैं. Okay, right? So if I convert any function into algebraic, then the further process will become very easy for me. वो मेरे लिए बहुत easy हो जाएगा. ठीक है ना? तो Laplace transform is a function which converts the function into algebraic and which is very widely used in solving linear differential equations. Okay, linear differential equation. This is a very powerful mathematical technique. Okay, and it is introduced by Laplace while developing the theory of probability. इसलिए उसको नाम बोल दिया है. It is known as Laplace transforms, right? So it is also used to solve simultaneous equation. Now, if you can see this GIF, देखिए क्या है. What is this? Differential equation. ये differential equation है. उसे अगर आपने Laplace transform के funnel में डाल दिया, तो it will give you algebraic equation. If you solve that algebraic equation, you will get some solution. And if you get its inverse, if you apply inverse Laplace transform, then you will get your solution in time domain. Okay, this is the explanation of this Laplace transform ka advantage. Fine. What is the advantage of Laplace transform? We are also going to solve differential equation using Laplace transform. Okay. Now, it is applicable to continuous function or piecewise continuous function, periodic function, step function, and impulse function. Okay. It has very important applications in mathematics, physics, optics, electrical और यहाँ पे आपका BEEE में भी शायद आप लाप्लास का बहुत यूज होता है सिग्नल प्रोसेसिंग और उसमें. फाइन. दिस इज अ वेरी इजीएस्ट मेथड, ऐसा बोला गया है. द ऑपरेटर फॉर लाप्लास ट्रांसफॉर्म इज L, कैपिटल L. If you apply Laplace, अब कैसा बोलना है? Apply Laplace on any given function which is in term of t. Laplace of function of t will be written as function of s, where s is a parameter. It may be a real value or complex value. Okay, parameter. It doesn't mean that it is a constant. You may have real value, complex value, or some variable also. Fine. So Laplace of any function ft will be converted into algebraic function, which is function in S, and written as f bar of S but generally we are going to use capital of Fs. These both are the same notation. If you apply Laplace on any function, you are going to get this function in term of S. Ft be a function of t defined for all positive values of t, then the Laplace transform of Ft denoted by L of Ft, it has this definition. Integration of e raised to minus st ft dt from 0 to infinity. If you integrate within 0 to infinities, okay, this is the definition. So you cannot say that's minus infinity to infinity. ये नहीं बोल सकते आप उसे. If your limit is minus infinity to infinity, then that Laplace transform is known as dual Laplace transform. But here we are doing simple Laplace transform. Okay, so our definition will be, we'll take the limit from 0 to infinity e raised to minus st ft dt. If you integrate, you are going to get the answer in term of s, provided that integral exists, where s is, ये s क्या है, ये आपका real और complex number है. Okay, so if I ask you what is the definition of Laplace of any function, तो आप क्या बोलोगे? Integration from 0 to infinity e raised to minus st ft dt. Right? All of you have understood this integration? याद रहेगा?
Ma'am, can you repeat it, please?
What do you want me to repeat?
Okay, I understood.
Little bit louder, yeah. We will have some transforms of basic functions. है ना? हमें Laplace find करना है. We want to find Laplace of given function. Then how to find the Laplace of given function? The sufficient condition for existence of Laplace is this. S is greater than A. I'll explain you while solving the Laplace transform of some basic function. Okay, तब मैं ये condition बताती हूँ. The function which is given, it should be continuous, है ना? And the limit of e raised to minus atft is finite. ऐसे होना चाहिए, right? Now, how to find Laplace of any function? यहाँ पे, if you can see over here highlighted, Laplace of 1 is written as 1 upon s, where s is greater than 0. है ना? S is greater than 0. If s is equal to 0 अगर लिया हमने, तो 1 upon 0 क्या बन जाएगा?
Infinity.
Infinity. इसलिए ये condition बताना जरूरी है, right? Okay. I want to find Laplace of 1, and we know very well that Laplace of any function is integration of this. Where? What is my ft? ft क्या है मेरा? What is ft given as? Compare करो इसके साथ.
1.
1, right? So wherever there is ft, what you are going to write?
1.
1. Okay. E raised to minus st 1 dt 0 to infinity, right? Is equal to. बताइए, what is the integration?
E raised to minus st into minus s.
Into?
No, by minus. Upon minus s.
Right? Between 0 to
infinity.
Right? Okay, chaliye. E raised to minus, I want to put the limit in place of t because I am taking t integration with respect to t. So t is my variable and s is my parameter, right? So e raised to minus s into infinity. Okay, upon minus s minus e raised to 0 upon minus s. You can take out minus s common also. Minus 1 upon s. E raised to minus infinity. Is it written as 1 upon e raised to infinity? Yes or no?
Can you repeat once again?
Listen, S is your parameter. Any
Yes, ma'am.
parameter multiplied with infinity gives you infinity.
Yes, ma'am.
हाँ, तो e raised to minus infinity कैसे लिखा जाएगा?
1 upon e to power
1 upon
infinity.
e to the power infinity. And 1 upon e to the power infinity is what? 1 upon infinity. Yes or no? E has some value 2.718182. Is it?
Yes, ma'am.
हाँ, उसका raised to infinity will give you the value infinity. So 1 upon infinity will become what?
0.
0. So 1 upon e raised to infinity ये पूरा 0 बन जाएगा. Minus e raised to 0 is 1. मैंने माइनस s दोनों में से कॉमन साइड पे ले लिया है. This minus gives me plus, and I got my answer. And
Yes.
this will become 0. Is it?
Yes, ma'am.
Understood?
Yes,
So,
ma'am.
for any function, if you want to find Laplace, okay, for any function, if you want to find Laplace, then use this definition. Use this definition. So, you can see over here. Proof है यहाँ पे मैंने करके दिया है. I have substituted ft over here 1. Then I have taken its integration. Then I have substituted the limit e raised to minus infinity, e raised to 0 upon minus 1. And I got minus 1 upon minus s, which is 1 upon s. Okay? If I ask you what is Laplace of 1, what is the answer?
1 by s.
1 by s. If I ask you what is Laplace of k?
K by s.
K by s. Okay? Because Laplace transform will also follow the linearity rule. Means you can take out this k outside and can write L into 1. Linearity property hai Laplace ki. There are certain properties of Laplace. So you can write like this k into 1, and you know what is Laplace of 1. You have already proved. Or if you want to find the Laplace of any constant k, तो यहाँ पे k substitute कर दो जहां पे 1 है. Substitute कर दो k. K will be outside. है ना? तो k upon s is the answer of Laplace. K Laplace of 1 and k Laplace of 1 will give you k by s. K 1 by s is k by s. Understood?
Yes, ma'am.
What is Laplace of 2?
2 by s.
2 by s. What is Laplace of 3 by 4?
3 4s. 3 upon 4s.
Done. Fine. याद रहेगा?
Yes, ma'am.
Yes. So this is your first formula of Laplace. Laplace of 1 is 1 by s. Same like that. Laplace of e raised to at. We are finding some standard function ka Laplace. Laplace of 1 is 1 by s. Now I want to find Laplace of e raised to at. So use the definition of Laplace. This is the definition. What is your ft over here? क्या है?
E raised to 80.
80. Your ft is e raised to 80. Okay, fine. E raised to 80 substituted in place of ft. Then simplified. कैसे simplification किया है देखो. Whenever you have infinity power, e का power negative ही बनाना है always. Then and only then you will get some value or some answer. ठीक है? So here you can take out minus sign outside. So s minus a into t. Now one more thing. You are not going to ask the proof of all these functions. No one is going to ask you this. इसका proof बताओ. Prove that Laplace of e raised to 80 is this. No. But yes, Laplace of e raised to 80 is 1 upon s plus a. This formula can be asked for MCQs. Done? Huh?
Yes, ma'am.
But
Yes.
how we got, sorry, this will be s minus a, huh? Not s plus a, s minus a. But how we got this value, वो मैं बता रही हूँ. ठीक है ना? Listen. So what we did, I have taken out minus sign common, s minus a into t किया, and then I have taken the integration of this term. So this is my constant value, and वो dividement हो गया. And if you substitute the limits, you are going to get this answer, 1 upon s minus a, where s is greater than a. Why this condition is there? What if s is equal to a over here?
Infinity. 1 upon
Infinity. That's why you want to show this condition. You have to show this condition, s greater than a. Fine, na?
Yes,
So,
ma'am.
what is Laplace of e raised to at? Is 1 upon s minus a, where a is s is greater than a. Okay. Now, if I ask you, what is Laplace of e raised to 2t? Bolo?
2 upon s minus a.
No.
1 upon s minus 2.
This is your a.
Yes, ma'am. Got it. 1 upon s minus 2.
1 upon s minus 2. Done?
Yes, ma'am.
Yes. What is Laplace of e raised to 7 by 2t?
7 upon 2s minus 2.
2 by s minus 7.
We would just place in. Yeah.
क्या गड़बड़ कर रहा है?
2s minus 7. Sorry, 2 upon 2s minus 7.
2 by 2s minus 7.
2 upon 2s.
सही है. Done ना? Okay. Easy है?
Yes, ma'am.
Yes. If I ask you, what is Laplace of e raised to 2 e raised to 3t? Come on. Linearity property says Laplace of a of ft is says a को side पे ले लो, take out a means constant aside and write down your function. Standard function है ये. Now 2 into what is e raised to 3t का Laplace?
1 upon s minus 3.
1 upon s minus 3. Done. So 2 upon s minus 3. So now what you are doing? You are applying Laplace. Understood? You are applying Laplace. Now there is a small change. Saying, if I want to find Laplace of say e raised to minus 2t, then what will be my a? मेरा a क्या बनेगा? Will it be minus 2?
Minus 2.
So in my this formula, s minus of minus 2. तो ये क्या बन गया?
Positive.
Fine.
Yes,
So,
ma'am.
so same like this, can I write Laplace of e raised to minus 80?
Yes, ma'am.
है ना? तो क्या फॉर्मूला है? 1 upon s plus a. याद कैसे रखना है? How to remember? If power is positive, a is positive, तो यहाँ minus. If a is negative, तो यहाँ पे plus. Formula is same. 1 upon s plus a, 1 upon s minus a. And s is greater than minus a. Understood? So till now, how many formulas we have seen? Total formulas?
3.
3. Laplace of?
1 upon s. No, Laplace of 1. 1 or k.
बड़ा मजा आ रहा है मुझे तो. ठीक है. Laplace of जी, Laplace of 1 is 1 upon s. Laplace of e raised to at is, बताइए, negative या positive?
1 up. Negative.
Negative. And Laplace of e raised to minus at will be 1 upon s plus a.
Okay.
ठीक है? चलो, 3 formulas learn हो गए?
Yes, ma'am.
याद रहा सबको?
Yes, ma'am.
Okay, good. Same like that. Laplace of sine 80. Use the definition, substitute ft cosine 80, and this is the standard integration ka formula. Apply it and put the limit. You are going to get sine of 80. Laplace of sine of 80 is a upon s square plus a square, where s is greater than 0. Understood? So what is Laplace of sine 80?
A upon s square
S
plus
square
b
plus
square.
a square. हमें तो फॉर्मूला से मतलब है ना? All of you know ना, this is the formula in integration. e raised to 80 इसका बहुत यूज होने वाला है फूरियर सीरीज में. फूरियर सीरीज में इसका बहुत ही यूज होने वाला है. This formula, e raised to 80 sin bt. What is my a over here? If you compare with this, a क्या है?
Minus s.
Minus s. A is minus s. What is b over here? b क्या है?
A.
a है ना? तो देखिए अप्लाई किया है e रेज टू a t. e रेज टू a is minus s. a square. What is a? a is s है मेरा. What is a? Minus s square. What is b? a square. So s square plus a square. Okay. A sin bt. What is a? Minus s. A sin bt minus s sin 80. Yes or no? Apply
Yes, ma'am.
किया है, देखो compare करो. And then if you apply the infinity limit, you are going to get a upon s square plus a square. So Laplace of sin 80 will be a upon s square plus a square. याद रखना है. Same like that, if you find the Laplace of cos 80, तो e raised to 80 cos bt वाला formula, it is also standard formula in integration. You can use this formula and can find the Laplace of cos 80 also. So if you are going to find the Laplace of cos 80, तो वो मिलेगा आपको s upon s square plus a square. Laplace of cos 80 is equal to s upon s square plus a square. ये मिलेगा. Okay. Now, what is Laplace of sine of 3t? बोलो.
3 बट्टा s स्क्वायर बट्टा 9.
3
बट्टा
upon s square plus 9.
ओए बट्टा बट्टा किधर गया? कौन है बट्टा?
बट्टा
कौन बोला? अच्छा, how many are there? 55 means 40 plus 15. Okay.
बीजे
5 plus 20.
9 upon s square plus 9 4 36 upon s square plus 16.
Yeah. So how to apply Laplace for sin 40 cos 80 अगर है suppose. Laplace of cos 2t. बोलो.
S upon s square plus 4.
s upon s square plus 4. अच्छा, ये कौन बोल रहा है? आंसर कौन बता रहा है?
मैम वही आयुष राज.
आयुष राज. अरे तू स्टार्टिंग में तो बड़ा एक्टिव होता है, फिर धीरे 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 वो बलून की हवा कैसे दिया तोलाने का बच्चा निजामुद्दीन एक्सप्रेस से आई तो बी तो आता ही नहीं है इसमें.
Yes, ma'am.
Laplace of cos 80.
s square upon s square
S
plus a
upon
S square plus
S ऊपर स्क्वायर कहीं नहीं होता है. देखिए डिफरेंस, सी द डिफरेंस. हाँ, यहाँ पे साइन में a होता है, कॉस में s होता है ऊपर, नीचे डिनोमिनेटर इज सेम. ठीक है. e रेज टू 80 e रेज टू माइनस 80 में न्यूमरेटर 1 1 होता है, डिनोमिनेटर में आपको बता दिया मैंने की ऑपोजिट साइन होती है, s प्लस ए s माइनस ए. तो हाउ टू रिमेम्बर? लाइक दिस. सेम लाइक दैट, लाप्लास ऑफ साइन ऑफ हाइपरबोलिक ऑफ 80. We all know that लाप्लास ऑफ साइन ऑफ हाइपरबोलिक ऑफ 80 का यूलर्स फॉर्मूला बताया था ना मैंने लास्ट सेमेस्टर में. लाप्लास ऑफ साइन ऑफ हाइपरबोलिक ऑफ 80. Yes or no? All of you have remembered this formula? Do you remember this formula? अगर नहीं तो ये इसका फॉर्मूला है एक्सपोनेंशियल फॉर्म में. साइन ऑफ हाइपरबोलिक ऑफ t e raised to t minus e raised to minus t upon 2. Okay, so what I did, if I want to find Laplace of sine of hyperbolic of 80, am I audible?
Yes,
Yes,
ma'am.
ma'am.
हाँ. Okay, so sine hyperbolic of 80 को इसका फॉर्मूला लिखना है. You can write this formula and multiply it inside with e raised to minus st e raised to 80, e raised to minus st e raised to minus 80. Multiply किया. ये this 2 1 by 2 taken outside.
मैम
जी
मैम शायद मैं मिस प्रिंट हो गया उसमें.
क्या?
इसका फॉर्मूला बुक में दिया ए बट्टा मैम ए बाई एस स्क्वायर मैंने से स्क्वायर दिया हुआ है.
हाँ.
मैम पकड़ा के बट्टा वाला.
Very good. Very nice. Thank you. Okay. तू बुक लेके बैठा है?
हाँ, वो रेफरेंस बुक लेके बैठता हूँ.
Very nice. Good. Keep it up.
मैम टॉपिक देखना पड़ता है ना मैम, कुछ कौन सा पढ़ा कौन सा.
हाँ, एकदम सही है. Good. So e raised to minus st e raised to 80 dt. ठीक है, मैंने क्या किया? ब्रैकेट मल्टीप्लीकेशन किया और यहाँ पे भी ब्रैकेट मल्टीप्लीकेशन. In between this minus is there. What is this definition of? ये क्या है? किसका definition है ये?
Hyperbolic function.
Excuse me, ma'am.
Yes.
My name is Manish.
Yes, who is this? ये किसकी definition है? Who will tell me?
Laplace transform.
अगर आपको ऐसा बोला तो you are using this definition, right? E raised to minus st and ft dt. ऐसा लिखते हो ना? If this is ft, अगर ये ft है तो. Now, if Laplace of e raised to 80, then how you are writing? E raised to minus st e raised to 80 dt. Is it? तो अब ये है आपके पास, तो उसे मुझे लाप्लास के फॉर्म में लिखना है, तो वो कैसे लिखूंगी मैं? फंक्शन के फॉर्म में. ये डेफिनेशन किसकी है? तो आप क्या बोलोगे? लाप्लास ऑफ e raised to 80 की डेफिनेशन है. What is your ft? E raised to 80. Other than this term, e raised to minus st is already there. ft is always changing. ये ft change होता है हमेशा. This is already there. तो अगर मैंने पूछा ये किसका डेफिनेशन है, तो आप क्या बोलोगे? लाप्लास ऑफ ft. तो what is this definition of? Laplace of e raised to 80. What is this definition of? Laplace of e raised to minus 80. Is it?
Yes, ma'am.
हाँ. तो after that, you know very well that Laplace of 80 का फॉर्मूला क्या है? What is Laplace of 80? 1 upon s minus a. E raised to minus 80, 1 upon s plus a. Simplify करो, LCM, and then if you simplify, you are going to get Laplace of sine of hyperbolic of 80 is a upon s square minus a square. What is the formula of Laplace of sine 80? देखो क्या फॉर्मूला है Laplace of sine 80 का?
A upon S square.
A upon s square plus a square.
Plus a square, है ना? And what is the formula of Laplace of sine of hyperbolic of 80? What is the difference?
That's the
हाइपरबोला में नीचे जो डिनोमिनेटर है इंस्टेड ऑफ प्लस इट इज माइनस, ऐसे याद रखना है. Sine of hyperbolic of 80 is a upon s square minus a square. If you don't remember this formula, आगे का काम नहीं कर पाओगे. So it's better, ये आज जो 6-7 formula मैंने बताया है, next lecture में be ready with this formula. Same like that, if you want to find the Laplace of cos of hyperbolic of 80, तो आप कौन सा formula याद रखोगे? Cos 80 का. What is that formula? S upon S square plus की जगह पे minus. That's it. This is the difference between these two formulas. This and this. Done with this?
Yes, ma'am. Got it.
Huh?
Yes, ma'am. Got it.
Yes. So remember the formulas. How we have proved this also.
मैम
बोलो.
मैम यहाँ पे एस हमेशा पॉजिटिव होगा ना?
हाँ.
अगर नेगेटिव हो तो क्या हो जाएगा?
नेगेटिव है तो नेगेटिव का जनरली हम लोग है ना पैरामीटर को पॉजिटिव ही लेके किया है, इसलिए उन्होंने यहाँ पे देख मॉड ए लिया है.
हाँ उसीलिए पूछा.
हाँ मॉड ए लिया है, तो माइनस भी अगर ए है तो मॉड ए बोला ना, एस इज ग्रेटर देन मॉड ए, तो वो पॉजिटिव बन जाएगा.
ठीक.
डन. चलो. ओके, सो वी हैव सीन टोटल 7 फॉर्मूलास. चाहे ये नंबर 6 दे रहा है, लेकिन हमने टोटल 7 फॉर्मूलास देखे, राइट?
Yes, ma'am.
Now there is one another formula which is really important, is Laplace of t raised to n. Laplace of t raised to n is n factorial over s raised to n plus 1. This is already proved in your textbook. मैंने यहाँ पे इसका प्रूफ नहीं लिया है. हाँ. So अगर मुझे ये लिखना है, suppose I want to find Laplace of t raised to n. So with the definition, how should I write? E raised to minus st. What is my ft over here? ft क्या है? t raised to n, है ना? t raised to n dt. So t raised to n, where n is very, means how, what is n? We don't know n, right? तो इसका आप टेक्स्ट बुक में थोड़ा देख लेना if you want, otherwise formula याद रखना है आपको. So when is this formula used? N factorial over s raised to n plus 1. इसका यूज कब होगा? When n is starting from 0, 1, 2, 3 integer. अगर वो फ्रैक्शन है other than this value, नेगेटिव भी है या तो फ्रैक्शन भी है, if it is other than this value, then you can use this gamma n plus 1 upon s raised to n plus 1. And all of you must know how to find gamma n का value. या gamma n plus 1 is n gamma n, पता है आपको, right? So I'll give you one example. इसका proof हम नहीं देखेंगे. So for these values, when to use this formula, Laplace of t cube, which formula will you use? गामा वाला या सिंपल? अगर मैंने बोला गामा वाला तो ये वाला फॉर्मूला, सिंपल तो ये वाला फॉर्मूला. फाइन. Which formula will you use? Come on.
सिंपल वाला मैम.
सिंपल वाला. क्या लिखा जाएगा?
3
factorial upon
s raised to
s
4.
raised to 4. ठीक है ना? हो गया आंसर. 3 factorial is 6
by s raised to 4.
raised to 4. If you have Laplace of t raised to 3 by 2, बोलो. Will you use this formula?
Gamma formula maybe.
Gamma वाला. Yes, gamma. Gamma 3 by 2 plus 1, है ना? n plus 1 बोला है. n is 3 by 2 upon s raised to, can I write 5 by 2 directly?
Yes.
So ये है gamma 5 by 2. अपॉन s रेज टू 5/2. गामा 5/2 का वैल्यू चाहिए मुझे, बताओ. Who will tell me? गामा हाफ की वैल्यू क्या है? रूट पाई. Understood? Into 1 upon s raised to 5/2. This is the answer of Laplace of t raised to 3/2. Understood? Topic for today. But I'm going to share all this PDF. अब ये PDF में मैंने